one you do understand, but just now we have the two NAND, right? This is the two NAND output, and then like I said, if you want to have a AND circuit, you just place inverter layout, and then you will have the output of AND. First, you construct two NAND. Second, you can construct the inverter and you get the AND. Alright. This for this part, for optimize the layout, if we have this type of schematic, it will give you yeah, you can actually draw different layout and they will produce the same answer. However, their output delay may not be the same. Means that you will going to have different capacitance or resistance, and this may affect the drain output or the delay because delay is related to RC. So what does it mean by that? Is actually okay, this is a NMOS, right? So in order to construct this, you need to start from NMOS, and parallel of this is actually you have a if this is BCD are in parallel, so you're going to have this one opposite, so it should be in series. Okay, BCD. So this is B, C, and D. Okay, what about A? Since BCD and A here, they are in series, so you need to construct it in parallel to contact the A. And the source here connected to VDD. And the drain side should be connected to the, this is the output, or over here they put F. Okay, so what does it mean here? So not all layouts are created equal, even though you can have the same function. Over here the function F is the output, is equal to, since B, C, D are in parallel, so you're going to have and A is in series, right? So you're going to have a B, C, and D, they are in parallel, so in series with A, so you're going to have to invert the overall output, so you get this. So you're going to have the same function here. I will show you the second slide, but if you look at the how to construct a layout, you can see you can have the same layout, but the drain is the delay output will be different. So over here you're going to have 1, 2, 3, and 4 drain capacitance. So when you have a contact like this, you're actually going to have 4 drain capacitance. What does it mean by 4 drain capacitance? It means that at the output here, you're going to have a capacitance, 4 capacitance at the output. Sorry. Okay. So over here, you're going to have the C, which is equal to 4. What does it mean? It means that the delay will be higher. So you do not want this. You want to reduce the delay of your circuit, right? So how to reduce that? You can redo the construction of this layout. Maybe to the next slide. If you look at here, still the same, but the only things, if I put this one F, output F, and this is the ground, right? The BCD, if you write the function here, the BCD are all in parallels, B, C, D, and in series with A, you're going to have the same functions, right? But if you look at the construction here, the layout construction, they are different. So how many drain capacitance they have? This is output, so you have 1 and 2, only 2 output drain capacitance. So you actually reduce the delay, right? The output delay. So over here you have only 2 capacitance. Reduce the delay. This is a good design. So in your lab, in your project, you're going to reduce the delay, the output delay. Yeah, okay. So how to check whether this is correct or wrong? If you look at here, the B, C, D, they are all connected to the ground here. So if you look at here, this is B and C. It is connected in between the B and C, right? So you have a middle contact at here. And the D here also contact to the ground. So you have a D side here, which is contact to the D. Okay, so this is done. And then you need to contact to A. B, C, D here, contact to A. So if you look at the C and D, they have contact in the middle here. Okay, and then C and D done. C and D both are contacted, and they need to contact with B. So you have to put a metal here and contact to B side. Since B and A are sharing the diffusion with A, so you actually have all contacted to the A side. So this is done, right? This part is done. And then the A side here should goes to the output F. So over here you're going to have this one. This is A polysilicon, right? The input is A, and then should be contacted to the output. So A contact to the output F, and then over here, why they put it like this? You need to extend the PMOS side. So you have a BCD, they are in series, because this one in parallel, so you should have a polysilicon in series. Okay, and since A with a BCD here are in series, so you should have a parallel at this part. And this is a VDD, so you have A here, and here are BCD. Okay, all right. Okay, so how to put this one? Maybe I put this one as D and this B, so that it is related to the figure we have here. Okay, so this output of F here, let me use pointer. The output F here should be contact to the drain side here should be going to the B side and A of the drain side. So since this is a polysilicon of A and B, and this is the output, you need to contact in the middle, put a contact in the middle of B and A. So you have both are contacted. And then the A side here, go to the VDD, and you know that this is A side, go to VDD at here. And then if you look more, you have a BCD all in series. So because this is all in series, one series line here, right? And then the last part should be going to the VDD. So this is a D side, go to the source of D side should go to the VDD. This is a D, go to VDD. So everything is connected. I hope you do get this, inshallah. I forgot to show you how this one contacted. If you look at this side, this is a ground, the source side of A should be going to the ground. So you have a ground here. This is the A polysilicon. It should be going to this side of A, and then all B, C, D side here should be connected to the A. So you have a this is A and B polysilicon. Okay, and then you have C and D. And if you look at here, the C and D first contacted to the A. So we put a contact in the middle part of C and D, and we contact to the B side here, so that we have this to the B, right? And if you look at here, all A, B, C, D should be contact together. So that's why they put it one side here. And you have the C and D contact with this, and then go to the B. This is a B. Since the diffusion is sharing between A and B, then you have all contacted, right? And then F. What about F? This is the output here. Go to B, C, and D. Then you have the B and C here should have a contact, and go to the D side. Okay, so that the B, C are contact over here and with the D. So you have all contact to the output. And for the F side of PMOS here, the upper part there, you're going to have, this is in series, and this is PMOS. Why in series? Because you have a parallel at the NMOS, and the A side here is connected in, both are in series here, so you should have parallel at this PMOS side. And this is VDD up there. If you look at here, the output, this is output F, goes to D and A side. So this is F, go to the, this is D to A side. So both should be connect with VRC. So A and D contacted. And then since B, C, D are all contact using diffusion layer here, so we do not need to put any metal contact. And for the VDD part, this is a VDD, should be contacted to the B side and also to the A side, the source side here. So you have a A here and B here. You should put a metal in between these two, so you have it all connected, right? I hope this one clear.